A and B are straight lines. Line A has got that equation. Line B goes through those 2 points. Do they intersect? Well, all I actually need to do to say whether they're going to intersect or not is actually to see whether they're parallel. Because if the lines are parallel, I can say no, they won't intersect. If the lines are not parallel, then I can say for certainty that yes, they have to intersect. The only way that lines don't intersect is if they're parallel. If they're not parallel, they must. So that's all I need to actually show. I need to look to see, are they parallel? So do they have the same gradient? If they have the same gradient, they are parallel and they won't intersect. That's all I need to check here. Now, line A, I can actually get the gradient pretty quickly for this, because all I need to do is rearrange this to make y the subject. Because remember, if you've got an equation, y equals mx plus c, then you can just read off what the gradient will be easily. So in this case here, I've not got a y, I've got a 2y. But if I divide both sides of this equation by 2, I get y equals 3 over 2 x plus 4. So by dividing both sides of this equation by 2, I've now got the y by itself, and I can now see that the gradient of A is 3 over 2. So now let's look at line B. Slightly more work to get the gradient here. We've got 2 coordinates. We know that the gradient is the change in the y divided by the change in the x. So the change in the y coordinates here is 8 take away 2. The change in the x coordinates is 2 take away -1. 8 take away 2 is 6. 2 take away -1, so that's going to be a positive, so that's going to be 3. 6 divided by 3 is 2. So that's the gradient of line A, that's the gradient of line B. They are not the same. So they are not parallel. So they do definitely intersect. So I can say A and B do intersect because they are, or because they have different gradients and are not parallel. There we go. That's all we actually need to do for that question.